Rachuba Swiata, Measuring the World. If you want understand, mastering and control the world, it's a very, very hard job that you want to. And we can see that in our real world, in the currently situation, and we see that every time in our business world and our IT world. And I will give you some ideas, some inspiration how we can solve that. And perhaps Alexander von Humboldt and Carl Friedrich Gauss can help us. My name is Matthias Scholze from Warsaw, and my colleague Fabian Klose will help me then with a live demo. Daniel Keman has written a book, a bestseller, that called Rachuba Swiata, Measuring the World. And this novel with fictional part and with some historical facts tell a story about the both scientists if they try to better explain the world. I love this book very well, and in 2 months we have Christmas time, and if you're looking for a gift, that's my recommendation. Yeah. And they have a view to the planet Earth, so a nice world, and what they are doing is they observe the world, they inventory, they verify, and they evaluate it. Both in different kind of ways. They have different approaches that they are using. Alexander von Humboldt travels a lot of countries, a lot of continents that he visited, and in every country he was, he document animals, rivers, mountains, trees, plants, fruits, and so on and so on. Yeah. And Alexander von Humboldt is a crazy guy because every time he have a piece of poison in kind of a plant, he tested, yeah, because he was interested how strong the poison is and what the poison is doing with her body. Yeah? Crazy guy. Yeah? Carl Friedrich Gauss is the first guy that used home office, because he hated to travel, and the most common place for him was to sit alone at home and thinking about the world. And he present us things in the mathematics, in astrophysics, and something like that, Gaussian numbers, elliptic functions, normal distributions, and so on. For me, is Carl Friedrich Gauss someone that gives us instruments to understand the dynamic world. Dynamic world sounds like monitoring, sounds like a Dynatrace. Alexander von Humboldt document a lot of things. That sounds for me to inventory, and that is virtue, that what we are doing every day with Fabian. And let's have a view to the IT landscape. There we have also to observe, inventory, verify, evaluate things. And in real time, it means that we have to inventory the infrastructure stack. It sounds a little bit like a CMDB. Yeah? Bare metal server, hypervisor, cloud platform, network devices. And every time if I come to a customer, they have a lot of trouble to get the information in real time. Yeah? It's every time a project to know how much servers we have, how much RAM we use on our servers, and something like that. And we go a little bit further in Warsaw. We make the application stack inventory available. That means we can inventory the operating system, the running processes, the provided services, the configuration of the processes, folder structures, file configuration, SSL certificates, everything what you need for an application. We can document it automatically. And we have the business stack where we, for example, can inventory the identity management, the user, rights, groups, roles, and something like that. And how we do that? We have two software components that help us to inventory things in IT landscape. We have the one importer on the left side. You install it on a server host, and then we are able to inventory everything what is necessary for you, what is running on this machine. Yeah, the operating system, the processes, the services, and so on and so on. On the other hand, we have the one gate. The one gate gives us the possibility to inventory things in your network. For example, if you're using hypervisors, cloud platforms, containers, network devices, and so on. Especially the IBM mainframe importer we built together with the Polish company ZRace. All data that we can inventory, we push to our Warsaw asset and configuration inventory. That means we have near real time all information in a central database available for you from your landscape. And based on this data, we provide you with solutions. We call it solutions. That means that are functionalities that based on the data that we have stored in our asset and configuration inventory. And we have one API. That means it's an open API for you. You have every time access to your data in the asset and configuration inventory to integrate it in your pipeline processes, or you can use this in your reporting scenarios. And then we get a kind of, here you can see a domain model, where you find everything what you have in your IT landscape. And with Warsaw.io, we bring some unique added value features. Yeah? For example, if we inventory a host or a SSL certificate, you will find every time the current state of this component in Warsaw.io, but we historize everything. That means you don't find not only the current state, you find all changes of a SSL certificate, of a host, of a network device, and something like that. That means you have every time to go, the possibility to go in the past, and you can say, what was the state 3 weeks ago, for example. We have topology detection. That means if you inventory things from different data sources, then we have the possibility to find relation between each other. That means if you have a hypervisor, for example, then we found, or we can inventory virtual machines. That's nice, but it's more nice if we found the relation to the host, so that you can see in the end your system architecture in a complete way over all stacks that you are using. All import mechanisms are automated, 100%. That means it's very easy to configure an importer. You need 1 minute for one configuration. And in the most projects where we are involved, we need 1 hour for setup Warsaw.io. It's very easy, it's very fast, and then the data comes in, and now it comes better time to analyze the data from your infrastructure. Warsaw.io is acting in business real time. That means if you change something on a network device, SSL certificate or host, we can detect it in seconds, minutes, and we can update it, the state in Warsaw.io. And we are audit-proof. That means you can't manipulate the change history, or we have a component that we named governance risk compliance. That means if we found a policy and you have a violation, then you can't manipulate the things. That's why every auditor, if you make a certification, is happy if you can see the data that we provide in Warsaw.io. Yeah, the core, I told you, is the asset and configuration inventory, where we store all data. We provide ready-to-use solutions where you can execute some use cases. For example, we can detect changes. That's very important. And if you are a company with critical infrastructure, then it's a regulatory requirement that you can detect changes. We are able, for example, to monitor change request execution. Yeah, it's a cool thing to check if your, for example, service provider executes a change request very well. We have IT governance compliance. We bring with Warsaw ready-to-use templates of policies, for example, CIS benchmarks and other things. But you can also define your own policies to check a state of a container, of an application, of a certificate, of a configuration, whatever you want. We can detect vulnerabilities and exposures because we detect the technologies that you are using and the version in which the technology are running. And that's why we can give you an insight that you have a vulnerability in your environment, or that you use software where new patch is available, or that you use a software where the maintenance is not more delivered right now. We have some features on the enterprise architecture level, and we monitor services and experience, and all the solution create events and violations, and we have a risk management, and the most important thing on our risk management is that it's based on protection requirements. That means every one of you that use protection requirements, it's a cool thing that you have looked to Warsaw, because we bring protection requirement assessment to life. Yeah? And we use, for example, to order the risk that you have, like at SNIKE, order where you have to start with the risk. What is the highest risk in your environment? And every thing what we are doing is to reduce the IT risk and the costs. And my personal most highest motivation is to ensure the information availability and give you the chance to handle the complexity that comes with cloud, with Kubernetes, and so on. Okay, that's from my side, and now I will went over to Fabian, and seeing is believing, like Florian said, and that's why we show you some use cases now live.
Great,
Can we
thank you.
switch? Perfect.
Okay. So I would like to start in the core view of our inventory. That means that every instance, every asset has such a view. And what we are seeing here is an host. That's always a good first example. And because it's a real physical host, we can provide a picture of this host. So that's an Intel NUC mini PC located in our office in Berlin. And the first important information we are presenting here is the actual configuration of this specific host. And our business is to get the most detailed information about every asset inside here. That means if I expand the information of this host, we can see information about the operating system running on this host, so it's a Debian operating system. We can see the mounted disks or the network interfaces, information about the system itself. That's why we know it's an Intel NUC 10. And we gather information about the power supply, about the BIOS running on that system, or even the hardware. So we can see we are using here 2 physical RAM bars inside, and we also can see the manufacturer and serial number of these RAM bars. So all of these detailed information about a host or every other instance is what we call a digital twin. That means it's a digital copy of the real physical host, and we can now work with this data. And the first thing we are doing on what Matthias has said is that we are now observing the state of this host. That means if anything changes on this host, we detect this and document this. That means on the bottom, we see a timeline that says, okay, 16 days ago, there was a change on this host, and the change was the operating system version changed. And it changed from version 12.1 to version 12.2. So someone did an operating system update here. Or maybe another example, 21 days ago, there were multiple changes. The operating system kernel was updated, the capacity of a mounted disk was increased, and the host was also rebooted. So that's done by our agent automatically, and it's a form of documentation. And it's the core of our platform. This results in a great data source about the complete IT landscape, because we are not doing this only for this host, like Matthias said, but for a lot of hosts, for things running on that host, or network devices, or even cloud platforms. And we also learned, like Florian from Dynatrace today said, that it's not enough to give information, we also need to give answers. And that was a big part in our last months and years. And that's why things come in our mind to say, okay, we have documented these changes, and now we want to analyze and evaluate these changes. That means we want to evaluate every change, if it is a good or a bad change. Is it a planned or unplanned change? And with today's focus of security, we want, for example, evaluate if this change results in a new security problem. So maybe for specific for this operating system update for the Debian, we want now see what does it mean to have an Debian running on version 12.2. So we can bring information right into our inventory and evaluate the product Debian as an operating system running in version 12.2. We are doing this here in, we are giving them 2 states, and we can do this because we have integrated product knowledge about all products we can detect and all versions that they provide, and we can give them a state. So we see here, okay, we have a green ambulance, that's for us the state of the life cycle of this used version, and the shield is the security state of this version. And if I'm switching in the details, we can see what that means. So we have done 2 evaluations here. The first one is on the part of the security. Therefore, we're also using the CVEs, the public known security breaches, and this version has no known CVE. That's because it's green. And on the left side here, we can see our lifecycle check. So every product vendor says, or the most one says, how you should operate their products. And Debian, for example, says you should use a version that is stable. That is, you should always run it in the latest version of the release you are using, so the latest patch. And you should only use version that is in the maintenance period of the vendor. So that's the fact here. We are using a good version. And we just saw only one host, one operating system. But we have a lot more. So we just filtered this view here, right? And if I clear the filter, we can see a bit more. So much more technologies we have detected in the small environment here we are looking in. And we can take a look into another example, maybe a red one. So we detected container technologies or a Samba file servers running here and databases. Yeah, so that's maybe a good example. We have two MariaDB databases running, and they're using different versions. And one of them is okay in the matter of our lifecycle check, but it's not okay in the topic of security, because here there's a known CVE. And we give you a recommendation what are the next versions that are compliant against this checks, because the strategy for every product is provided by us, but it's completely customizable. If you want to say, okay, I don't want to use only the latest patch, I always want to use the latest release and the latest patch, you can customize this, and then you have a more specific check for maybe just one specific product. The other MariaDB instance running here is red in both checks. So we're seeing, okay, we are running version 10.5.21, and we know, okay, there is a new patch available, and our rule says, okay, we want to use latest patch, then we have to update this. Okay, so we started from a host, and now I want to switch to a different asset to give you an example of other assets inside our inventory. This, for example, is an SSL certificate, also important for security. And yeah, we also can see the actual state. There are other information because it's an SSL certificate and not a host. We see, for example, the algorithm used to create this SSL certificate, or the length of the key used here. And we cannot do an technology lookup here for the SSL certificate. So what we are using here is we are using our own policy engine, and the policy engine is something we have for a long time now, but we learned it's not enough to give you the policy engine and say, okay, now you can create policies. So we had to learn, we have to give policies to you. We're bringing in expert knowledge, bringing your content packs with policies, and we can see them here, for example. But you have always the possibility to create your own policies if you want. We can see here, for example, here are 5 policies checked for this SSL certificate. The easiest one here, I think, it's we only want to use SSL certificates that are in the validity period, so it's valid. And we don't want to use SSL certificates that are using wildcard, because it's a bad practice. So I'm also can here jump to a bigger view where more policies are checked. For example, we're detecting and checking containers. So for security reasons, containers should not run in a privileged mode that allows them to exit the container and do things on the host underneath the container. So that can be checked here. And we have 33 containers here checked, and all of them are okay. But not every policy have to do with security. Some of them are maintenance things or hardening things. Here's an example of we are using a MariaDB resource, and we are checking, because we not only inventory the MariaDB, we also inventory the database schema used inside the MariaDB. And we have a policy here that says, okay, it's not too good to use some words in the DB schema for table names, column names, or whatever, because it's not forbidden from the vendor, but the names are used for functions or something like this, and this results in some problems or bad experiences. So we can have a look here, because we have 3 things that are not compliant here. And there's a list of things. In this case, there are column names checked, and it's, for example, not allowed to, or it's allowed, but it's not good to name a column accessible or add or all. And we have 3 tables where some names are used that are not that are in this list. So here, for example, we use in our rules table a column that is named condition. And that's nothing bad against security, but it would be better that we don't had this non-compliant thing here. So there are a lot more things checked. For example, SSH configuration. So it's we are checking here if it's allowed to use the root user to log in via SSH, and that's also a security thing and bad practice to disable this kind of configuration. So everything can be checked, and the learning here was that bringing a lot of policies that every of our customer had to create by themselves, and now we use expert knowledge from product vendors and experts for operating a database and recreating policies, or we use other sources like sys benchmarks for creating these policy sets and bring them into our platform so that every customer can use them.
Can you show us a topology, please?
Matthias said something about the topology and what the topology means, and it's an important feature in our platform because we have a lot of data in here, and we also need to filter, give you chances to understand relation between things and also focus maybe on a small part. So maybe you are responsible for just one application and don't want to see the MariaDB from your neighbor. We use topology. So we detect, we are starting here, we're looking right now into an application topology. So an application uses services. For example, here are some queues, web services. We are seeing the services are provided by processes. We are also seeing the technology here. So the message server here is a RabbitMQ. These processes are provided by Docker containers, and these Docker containers running on a virtual machine and host, but that's a virtual machine from a cloud provider. In this case, it's an Hetzner virtual machine, and we also inventory the information from our cloud provider. That means we bring the host information together with the virtual machine information and everything that is related to this host. Yeah, and then we can use topologies to filter the views where we just shown. So maybe I can go back here. For example, we have the technology overview, and I can use these topology we just saw to filter this view and to start maybe fixing things for this part of this environment. And also maybe here to mention, we decided, because we did not do this at the beginning, we decided to also show the green ones. So it's a good feedback for someone and not only the red parts. So for us, it's more motivating to see, we have something, we're doing something good, but something not so good, but we're seeing the transformation from a lot of red to more green.
Thank you, Fabian. Yes, if you want to understand, if you want to master, if you want to control your IT environment, perhaps Warsaw.io can help you to inventory your whole landscape and to operate on this data for security, for policies, and for a lot of other stuff that we have here in Warsaw. And please feel free to talk with us here on this conference, or to go to Jacek, to Tomasz, to Rafał, from our friends from Omnilogy, if you are more interested in a live demo or something like that. Thank you.